Welcome to Digital Electronics and Computer Organization video lecture. In the last video, we covered number systems and number conversions. In the second video, we are going to cover a ones complement and twos complement representations. Let us start what is a complement and what is ones complement, what is twos complement with an examples, and also how to perform subtraction using ones complement and subtraction using twos complement. Let us start the session. So in this module, we are going to cover and we are going to learn what is ones and twos complement representation. Before going to commence this ones complement and twos complement, you need to know what is a complement. So the complements, these are used in digital computers or digital electronics in order to simplify the subtraction. So subtraction, digital number of subtraction in the sense somewhat complicated, but by using complement representations, we can solve this subtraction in simple manner. So complements are used in digital computers to simplify subtraction. So that's why we are telling to simplify subtraction, operation, and for the logical manipulations, these complements are used. Right. So for binary number system, we will be having two types of complement representations. One is ones complement representation, the other one is twos complement representations. Further, we will be having a nines complement and tens complement, but here we are discussing about only the binary. For binary number system we are discussing. So for binary number system, we require only two types of complement representations. One is ones complement representation, the other one is twos complement representation. So let us see what is first, what is ones complement representation. So here in the ones complement representation, in the sense it is the process of converting binary number from 0 to 1 and 1 to 0. Right. So the process of converting the binary, the given binary number, if it is 0, it will convert to 1. If the binary number is 1, we will convert to 0. Right. So the process of converting given binary number to ones complement is inverting. Means inverting the given binary number. The process of converting given binary to ones complement is inverting the given binary number. So let us see one example for this one, how to convert the given binary number to ones complement. So coming to the example, I am taking 1 0 1 1. Right, I want to convert these to ones complement representation. Already I said you, the process of inverting the given number is said to be ones complement representation. So here the process of inverting the given number, in the sense 1 will be converted to 0 and 0 will be converted to 1. So 1 is converted to 0, 0 will be converted to 1. Similarly, 1 is converting to 0, 1 is converting to 0. So this is the given number. So this is the given number and this is the ones complement number. This is ones complement number. So the given number is 1011. Ones complement is inverting the given number. So we are inverting the given number 1 to 0, 0 to 1. That is the process of inverting the given binary number. That will be called as ones complement representation. Next, we will see the twos complement representation. So in this twos complement representation, we need to follow two steps. The two steps are, the first step is we need to invert the given binary number. That is the first step here I am having. So what is the first step? Inverting the given binary number. What is the second step? Add 1 to the LSB of ones complement number. So first we need to convert the given binary to ones complement representation. So after converting the ones complement, after converting to ones complement, to that ones complement to the LSB. What is meant by LSB? LSB represents least significant bit. So LSB represents least significant bit. LSB, least significant bit. So for any of the binary number, you will be having MSB and LSB. Suppose this is the number 1011. This one called as LSB, means least significant number, and this will be called as MSB, most significant number. So the rightmost bit will be called as least significant bit, and the leftmost bit will be called as most significant bit. So the steps that we need to follow in order to convert to 2's complement number, in the sense, the first step is we need to invert the given binary number to the inverted binary number, that will be called as 1's complement number. To that 1's complement number, we need to add 1, that gives the 2's complement representation. Let us see one example. So the given number is 1 1 1 1, right. So this is the number, given number is 1 1 1 1. So what is the first step? I need to do the inversion of the given number. So in the inversion of the given number is 0 0 0 0, right. So the given number is 1 1 1 1. The inversion of that number is 0 0 0 0, right. So this is the first step. So what is the second step? Step 2 is I need to add 1 to the LSB bit. I need to add 1 to the LSB bit. So if I add 0 0 0 0, if I add 1 to this one, then I'll get 0 plus 1 1 0 0 0. Right. So this will be called as 2's complement. 2's complement representation. This is 2's complement, and this is 1's complement, and this will be called as given number. So the steps that we need to follow in order to get the 2's complement representation is, for the given number, you need to get the first 1's complement. To that 1's complement, to the LSB bit, I need to add 1, then I'll get the 2's complement number. So before going to perform all this, you need to know the addition rule. So what is meant by addition rule? In the sense, if I add 0 and 0, means if I add 0 plus 0, the result means the sum is 0. Here you will be having two things, one is sum, the other one is carry, right. So sum is 0, carry is 0, means sum bit and carry bit. We will be having two bits while adding any two binary numbers. Then if you add 0 plus 1, sum is 1, carry is also 1. If I add 1 plus 0, then sum is 1, carry is 0. Similarly, if I add 1 plus 1, sum is 0, carry is 1. Because if I add 1 plus 1, in general, in digit we will call it as 2. But in binary, we are not supposed to represent it as 2. That's why it will be called as sum is 0 and carry is 1. Means that 2 will be represented in this form, 0 1. Right, 0 0 called as 0, 0 1, 1 0, 1 1, right. So here 1 plus 1, if you add in addition, binary addition, sum will get as 0, carry will get as 1. So you need to follow this principle while performing addition in 1's and 2's complement. This plays a major role. Right, means while doing subtraction using 1's complement, subtraction using 1's complement, these rules will be applied. Right. So these are the first primary things that we need to learn. What is 1's complement, means how to convert, how to get 1's complement and how to get 2's complement. So let's go with the procedure that how to do subtraction using 1's complement. So in order to perform subtraction using 1's complement in binary numbers, we need to follow some rules, like first of all we need to take 1's complement of the subtrahend. We need to take ones complement of the subtrahend. Second thing is we need to add with minute. We need to add with minute. And the third one is you need to check for the conditions that if the result means after performing addition with minute, subtrahend with minute, if the result that we are getting as carry bit, means if in the result if we are getting a carry bit, we need to add that carry bit, this one. If the result of above addition has carry bit 1, then add it to the least significant bit of the given result. Right, if carry exists after performing the operation, if carry exists, then we need to add to the LSB of the given result. If there is no carry bit, if the carry bit doesn't exist, then take ones if carry bit, no carry bit, right, then takes ones complement of the result, which will be negative, right. If carry bit exists, then we need to add that carry to the LSB of the result. If carry doesn't exist, then we need to take ones complement of the result. So that the subtrahend, we need to make a note that the subtrahend number is that to be subtracted from the another number. Right. So this is the procedure we need to follow while performing subtraction using ones complement. Let's see one example. Right. So here I am taking A is equals to 1 0 1 0. A is equals to 1 0 1 0 and B I am taking as 1 0 0 0. Right. So in general, what is A 1 0 1 0? That it represents 10. And B is equals to 1 0 0 0 represents the decimal number of 8, right. So what is 10 minus 8? You know it is 2, right. I need to get that result. So here in this, A will be called as minute. It will be called as minute and B will be called as subtrahend. B will be called as subtrahend. So what is the procedure? I need to take the ones complement of the subtrahend first. So B is 1 0 0, right. So I need to take B is equals to 1 0 0 0. This is subtrahend. So what is first the thing is I need to take this ones complement of the subtrahend. So the ones complement of this subtrahend is ones complement. So what is the ones complement for 1 0 0 0 1 1 1 means we need to take inversion of the binary number. So 1 0 0 0, the ones complement of this one is 0 1 1 1, right. So the first step I covered, that is I did ones complement of the subtrahend. So that ones complement I need to add to the minute. So what is minute here? 1 0 1 0, right. So to this minute I need to add this subtrahend. So 0 1 1 1, right. So if I add this, you need to follow that addition rule, that 0 plus 1 is 1. So 1 plus 1, you know, sum is 0, carry is 1. So sum is 0, the carry bit that we need to add to the next successive bit. So I need to add to the next successive bit. Now 1 plus 0 1, again 1 plus 1 0, sum is 0, carry 1, right. Now again 1 plus 1 0, right. 1 plus 1 0, 0 plus 0 0, carry I am getting, right. So this is the carry, right. So what are the rules? If carry exists, I need to add this carry to the LSB bit of the result. The carry bit should add to the LSB of the result. So if I add to this one, right. So what is this one? This one I am adding here to the LSB bit of the result. So if I add 1 plus 1 0, carry 1. So 1 plus 0 1, 0 0. So this is the final result. So 0 0 1, 0. So 0, 0, 1, 0 represents the decimal number of 2. So what are the numbers I took? A is equals to 1, 0, 1, 0. The decimal number that it represents as 10, and B is equals to 1, 0, 0, 0. The decimal represents as 8. So 10 minus 8, you know, it is 2. So the same thing that I performed here. Subtraction using 1's complement. So in the initial, the definition that we took, complements are used in order to simplify the subtraction. Means the subtraction we are doing by using addition process only, right? So this is the one example. So here I got carry, that's why I added to the LSB bit. If this carry doesn't exist, then you need to take the complement, this one, the complement if you take, then that will be the result, right? So this is all about subtraction using 1's complement. Let us see subtraction using 2's complement. So here also the procedure is same. The first procedure, that is, we need to take the, instead of 1's complement, here I will take 2's complement of the subtrahend. So after taking this one, at first you need to take 2's complement of the subtrahend. Right. So after taking the 2's complement of the subtrahend, I need to add it to the minute. I need to add to the minute. So if in the result, if carry exists, if the carry exists, then ignore that carry or drop that carry. That result represents positive. If carry doesn't exist, if no carry doesn't exist, then we need to take the 2's complement of the sum. Means we need to take the 2's complement of the result. If carry exists, I need to ignore that carry. If carry doesn't exist, I need to take the 2's complement. So what we discussed in the 1's complement, if carry exists, I am adding that carry to the LSB bit. Right. So whereas carry doesn't exist, I am taking the 1's complement of the result. So here also in the 2's complement, if carry exists, I need to ignore that carry. If carry doesn't exist, I need to take the 2's complement of the result. So I'll take the same example that I took for the 1's complement so that it will be clear for you. Then A is equals to 1, 0, 1, 0. The decimal I said it is 10. And B is equals to 1, 0, 0, 0, the decimal is 8. So what I need to do, I need to take the 2's complement of the subtrahend. So this is minute and this is subtrahend. I need to take the 2's complement of the subtrahend. So the 2's complement of the subtrahend, what is the procedure? The procedure that I need to do is, first I need to take the 1's complement of this subtrahend. So the 1's complement of the subtrahend is 0, 1, 1, 1. Right. So in order to get the 2's complement for this, I need to add 1 to the LSB bit. Add 1 to the LSB bit, then I'll get the 2's complement. So 1 plus 1, 0. Right. So 1 plus 1, 0. 1 plus 1, 0. Every time carry I am getting as I am adding 1 plus 1. Right. So 1 plus 1, 0. Now 1 plus 0, 1. Right. So this is the 2's complement. This is 2's complement and this is 1's complement. So I need to add this 2's complement to the minute. So what is A now? 1, 0, 1, 0. Right. So 2's complement I should add here, right? So 1, 0, 0, 0. Right. Now observe this one. 0 plus 0, 0. 1 plus 0, 1. 0 plus 0, 0. So 1 plus 1, sum is 1, carry is 1. Sum is 1, carry is 1. So what are the rules that I need to follow here in 2's complement subtraction using 2's complement? If carry exists, I need to ignore that carry. The rest will be the result. Right. If carry doesn't exist, I need to take the 2's complement of the result. Now, in this operation, I got 1 as a carry, right? So, I need to ignore this carry. Then, what is the result? 0, 0, 1, 0. That represents a positive number. It represents a positive number. So, what is 0, 0, 1, 0 represents the decimal? It represents 2. Right. So 10 minus 8 is 2. So in this way we need to perform subtraction using 2's complement. So in this video we covered what is 1's complement, what is 2's complement, how to perform subtraction using 1's complement, and how to perform subtraction using 2's complement. In the next video we will cover what is signed numbers and what are binary code representations. Thank you.